Hello, everyone. My name is Tingjin Chen. Actually, I just graduated from Columbia. I'm actually a postdoc at Yale. I'm joining Duke ECE in the next fall. And today I'm going to do some of these wireless and SDR tutorials as part of the Cosmos tutorial. So let's get started with the CISO channel sounding. So this is actually using the real-time sounder framework written in C++, developed by the Renew project. So let's say you have two radios in the CISO setting. So let's say the base station has one antenna and the client has one antenna as well. And we want to perform CISO channel sounding in the uplink. So how it works is basically that the base station keeps broadcasting beacons on the downlink, and the clients will start to look for the beacons by doing the synchronization with the beacon sequence. And once the client is synchronized with the beacon, it's going to schedule its upcoming uplink pilot and uplink data transmissions. And since the client is synchronized with the base station knows which slots it should be hearing the received pilot on the uplink or the received data package from the uplink. So essentially, you can log into the sandbox tool console using the SSH command. I can go to the file that configures the client. Right? So here, there's a file that configures clients, basically saying that I'm going to use the SDR number 2 on this IP address as the client, and then I'm going to set the front end gains of this device as these values. So the carrier frequency is 3.6 gigahertz. We're going to run the real-time bandwidth of 25 megahertz. Here, we're going to use a frame schedule, which basically transmits one pilot symbol on the uplink. That's indicated by this letter P here. So this is basically the setup for the client side. And here, since we're running a single channel, we specify the channel as using the channel capital A. And similarly, we can configure the specs for the base station. So here we use the same carrier frequency, we use the same single channel setup, and the same sampling rate or real-time bandwidth of 25 megahertz. And here, if you look at the frame schedule here, the first symbol B here represents the beacon the base station sends on the downlink. And then the letter P here means that once the client is synchronized with the base station is expecting to receive a pilot in this subframe. And here we also specify the IP address of the base station USRP in this file. So once everything is set up, we open two terminals. So we can run the client in one terminal and then run the base station in another terminal. So here, let's say on terminal number 2, I run the sounder client using the configuration file USRP client only. So this is basically going to trigger all the interactions with the USRPs to set up the frequency, the front end, the antennas. And as you can see here, the client is expecting to receive a beacon from the base station. So that's where the status is in terms of the client. And now I'm going to run the base station. It's going to follow the similar command. I can just run the sounder and use the configuration file as of a base station. So once this runs, you can see the similar steps that the server is trying to communicate with the USRP. And okay, let me stop this for now. So essentially, what you're going to observe here is that we use HDF5 file format to record all the samples. And you can see the command here basically says that the base station starts the main receiving loop, and it's going to record these many frames on the uplink. So on the other side, in the client, you're actually going to see there's a new line appearing here, which basically says beacon was detected as this specific timestamp on the FPGA. And then this is the synchronization offset between the downlink beacon and the uplink pilot. And once the client is synchronized with the base station, it's going to start its own transmission and receiving events on the uplink. So that's basically called after this start main loop command. So now we have all the samples recorded on the base station on the uplink. We can essentially run the Python script, which is also part of the Renew Lab software, to actually analyze the received samples on the uplink. So essentially, we go to this folder, which contains all the Python scripts, and we can simply run the script that plots all the samples with different metrics as part of the recorded HDF5 file. So here we just need to input the file name, which is the file that we just recorded. It's going to show up here. So this is the one that I just recorded. I believe it's 15. And then we're going to look at a specific frame, which is the frame number, let's say 1000. So once you run this frame and enable the X11 tunneling, you're going to observe the received samples, right? So here, essentially, you can see in the top 2 rows, the recorded IQ samples in that selected frame, which is frame 1000. And in the middle 2 column, in the middle 2 rows, you can see the aggregated received pilot across all the frames. So let's say if you zoom in here, you can see these are each of the chunks of the received pilots being recorded on the base station. So essentially, this shows the capability of doing the channel sounding on the uplink. And we can also do a similar thing in the MIMO setting. So essentially, let's open up the configuration files. And here, I'm gonna enable the client and base station to use both channels. So here, I just need to select channel A and B for the client. And here, I need to add another slot for the pilot. And similarly, for the base station, I'm gonna reconfigure the files of the base station and add another channel of B. And then also add another slot P here, where the base station knows where to receive the second pilot. And once we run this script, similar as before, we can observe the received uplink samples here. Right, so essentially, you can actually see this is the recorded pilot on the uplink, and also the concatenated samples from both channels. And here you can also see the recorded pilot from both users as well. So basically, this demonstrates the capability of running a real-time channel sounder. We're planning to add more UHD support so that this framework can actually support more than 2x2 MIMO sounding. Hopefully, we can run a small-scale massive MIMO sounding testbed using USRP SDRs as part of the Cosmos testbed.